Optimizing the gas consumption can make transactions and smart contract interactions more cost effective. If you are a developer or user of Ethereum blockchain and interested in learning about upcoming proposal, stay with us. Welcome to PEEPanEIP episode 118. I am Pooja Ranjan with another special talk on Dencun upgrade. Documented in February 2021, EIP-5656 Mcopy memory copying instruction is a standard track core EIP currently in review status. According to the proposal, EIP-5656 proposes an efficient EVM instruction for copying memory areas. To learn more about the proposal, we are joined by co-authors Alex Bergzazzi, Pavel, Bylica, and Charles Cooper. Welcome all to PEEPanEIP. As some of you may know, we like to kick off the talk with guest introduction, briefly about their professional background and their experience with the Ethereum ecosystem. It will be followed by a presentation to explain the EIP, and perhaps we will have some time for question and answer. So may I invite our guest to say a few words about themselves.
Hello, my name is Pavel Bylica, and first of all, thanks very much for having us again. And if I heard like 180 episode, I mean, that's a lot. So also big thanks, Pooja, for all the work you've done so far with this, and it's really amazing. I'm currently working on EVM research in the Epsilon team at Ethereum Foundation. I've been working with EVM for a very long time. I started in late 2014, also experimenting with some possible optimizations for EVM. And my kind of journey and professional work continues since then around this technology. Yeah, so we mostly experiment with some implementations of EVM, review proposals to EVM, and also propose our changes.
Yeah, likewise, as Pavel said, thank you, Pooja. This awesome work, and happy to be back again. As Pavel said, I'm also part of the Epsilon team. I didn't start as early as Pavel, but around like late 2015, and have been contributing since then to EVM research, as well as Solidity language design. In the past 2 years, I've been mostly really just focusing on the EVM research side. In the Epsilon team, we have a number of different proposals, including smaller ones like Mcopy and small number of instructions to fix like individual smaller issues we think are worth fixing. But we also work on much larger proposals like the EVM object format or EVM Max. But Mcopy is one of these changes which seem to be going live in the next upgrade. And I do have like a kind of fun personally of this change because it has been like a long pressing issue, and it kind of also addresses precompiles, which we in the Epsilon team are trying to really get rid of, or at least improve the situation around. And as you can guess, Mcopy has some relations to precompiles as well. You're going to see it during the talk. Yeah, that's in short about me.
Thank you so much.
Hi, yeah, I'm Charles. I do a lot of work on Vyper, and it's been my main role for the last couple of years now. And Vyper, as you may know, actually uses memory a lot. And I think I was talking with Alex, a year or two ago about this at DevConnect. And I was like, it'd be cool if we had this memory copy instruction. And he was like, yeah, we have the EIP, we should just kind of push it. So a few months ago, I think I realized that Cancun was coming up, and so I started kind of pushing this heavily on all core devs calls. And so I'm pretty happy that, we were able to, kind of, finalize the EIP and everything and get the support around it that we needed. And it's, it's a really nice instruction, and it solves, a lot of kind of performance and similar problems that you have when you start to write code for the EVM. So yeah, and thanks for having me on. This is my first time on this format. I understand it's been going on for a long time, so thanks for putting it all together.
Thank you so much. I would like to mention this team has been involved in EVM improvement for a very long time, as you may have heard Pavel and Axic talking about since 2015, and they have been extremely supportive of information sharing. In the past, we have discussed EIP-5860, limit and meter init code, EIP-3855, push 0 instructions, EIP-3540, EOF EVM object format. Most of them are deployed with earlier upgrades. So if you missed any of these talks, check the links available in description. Moving on to today's talk, without further ado, let's peep in.
So yeah, I would start with like brief introduction, what this is all about. I was actually checking where did we start working on this, because we have record of wrong reviewing EIPs waiting for being included in network upgrades. But it's not so bad. I think we did worse. I think it started somewhere in the beginning of 2021. So and there's more people also involved in preparing this. So please check the EIP itself with all the authors list. But back to the subject. So yeah, this is not a very sophisticated change. I think we can compare it in the complexity to, I would still compare it to like push 0 instruction that was added in the previous upgrade. This is instruction that helps with copying some areas of EVM memory, which is internally available to the executed program. So yeah, the EIP number is 5656, and this is scheduled for Cancun, and we don't really expect any surprises and like last minute removal from that. Although I'm not really sure what is the current estimated date of the shipment. I think people still might want to do it this year, but I'm not really sure that's the current deadline. If anyone wants more, please share that. But I think this has been implemented in the clients for longer because, as I said, the complexity of that is pretty low and it stays within the EVM. So this change doesn't really touch anything outside. So this makes it relatively easy to implement. So yeah, so this is simple instruction and it copies memory. Not so much, I think, again, this is not really surprising how it works. It mostly, the instruction takes 3 operands. One describes like the source index of the memory to be copied. One describes the destination index of the memory, where the area will be copied to, and you also specify the size of this area. I think it's explained, expressed in a number of bytes. I won't go into like deeply into details what exactly these things, how these things exactly specified, but I don't think that should be complicated to understand the details. And we also like pay a bit attention to what exactly you can copy with. So just wanted to present that this instruction handles copying non-overlapping areas of memory. They also can handle overlapping ones, and you can also copy backwards. So there are not really restrictions how you can use that. Also, the regular gas cost applies. So if the copying of the memory would extend the memory itself, you will pay this additional cost related to how EVM memory is priced. And yeah, we can talk a bit different areas of memory in the EVM. So starting from the top, we have call data, which is the input data the EVM execution will get. This comes from the transaction, from a parent call of current execution. And we can also have access to return data, which is kind of the opposite. This is the buffer from the data that like a child call would return to you. And both of these are read-only, so you cannot modify it, but you can read pieces of these. on the like basic execution level of EVM, we have a stack where the operands of the instructions are handled, and we have the memory, which we mentioned already. And finally, there's also a code, which means the code of the current contract that is being executed. So code is important as well because it kind of have this role of static data to the program. And this is also read-only. The difference between code and call data and return data is that the call data and return data is kind of coming from outside, and the current program can't really control it. So it's like external inputs to the execution. The code is something that the contract owns. And this can be used for internal static data, something like that. So, and there's different instructions that mostly allows you to move this data between these different kinds of memories. So we can bring some information directly to the stack. For example, call data load will bring a piece of data from the call data to the stack. And there's also direct instruction that can copy as some part of call data to the memory. So we can kind of skip the stack for this. And similarly for return data, there's a way to copy to the memory, but you can notice that there's no way to actually bring the return data directly to the stack. That is also something we may consider missing in the current design. The more basic instructions are these that moves stuff between stack and between memories. So we have mstore and mload instruction for these. And finally, there's a way to copy some data from the code to the memory. I think originally that was kind of imagined to be used for contract creation mostly, but I think currently languages use that also to start some smaller pieces of data. I'm not sure we want to actually have the way to move it directly to the stack. But I will leave this to Alex and Charles to maybe later comment on this. And how the Mcopy fits into this model is that it actually copies from memory to memory. So this kind of improves efficiency if you really want to do such operations. Otherwise, you would need to kind of use alternatives to this, which are much more expensive currently. Yeah, so that's mostly like my part. If you guys want to maybe add additional comments in terms of what you think is missing in this picture, I think they might want to have some opinions about it. But I think that's, at least for now, it's all from my side.
Yeah, I wanted to maybe add before we get to the next slide, that why would like memcopy being used, generally in languages. And I'm pretty sure Charles is gonna explain maybe a different viewpoint because Vyper works quite differently to Solidity. But the Solidity example is, looking at this chart, how you can obtain data. If you keep making external calls and you're assembling information to be passed to the external call, or you make a series of external calls, then you would be able to just keep copying like return data and whatever you have to assemble like an input for the next call. But if you think about internal calls within the contract itself, you may be in more of a need to manipulate memory and create like data structures, specifically where you may be able to moving memory. This, of course, not only applies to internal calls, but with many of if you only focus on external calls, then you may have a better chance at utilizing return data copy or call data copy. And the cases where this usually comes up is when handling arrays, and especially variable length data. Yeah, I just wanted to give some kind of an idea why would memory copying be happening at all. But on the next slides, we will explain what options there are today to actually solve this problem. I'm not sure, Charles, if you want to add your view on Vyper, how important memory copying is for Vyper.
Yeah, memory copying is super important for Vyper, and it's like kind of happening all the time. Basically, anytime you want to move a data structure, so like during ABI encoding, you're going to, like if you see return something, then that's going to copy data into a return buffer usually, or if you have an internal call. One thing is that Vyper generally stores more things in memory. So like an array or a struct or a byte string, those things are always going to be in memory. And then Vyper's internal calling convention also uses like these batch memory copies. So the kind of the places where you see memory copies that are going to happen are like internal calls, assignments, return statements, and a bunch of built-ins also do that. So like if you want to, concatenate 2 byte strings together or something like this. Yeah, I mean, so after Mcopy was kind of tentatively approved for Cancun, we have some internal routines in Vyper which for copying bytes, and I replaced those just from the identity precompile, and also there's some loops that are kind of unrolled for copying structs around and stuff like this, and bytecode size like came down quite a lot, like 3 to 5%, and gas is also improved. Yeah, so from the compiler perspective, having Mcopy instead of needing to, there's actually a question in the chat right now, why not mload and dupe and mstore? Well, it's because it's a lot more expensive and it takes a lot more code. So like maybe I should just like, oh yeah, we have the why slide next, like to give you an idea, like an mload mstore thing is going to take like 9 to 12 gas. I think that's just 12 gas to copy a single word. And then like if you want to do less than a word or more than a word, or it's not aligned, then you have to do more things to like, read and write back these unaligned things. And it also costs a lot in terms of bytecode. So like a loop, your very most basic loop is going to be like, I think 17 to 30 bytes of bytecode, which is a lot every time that you want to copy stuff. And even if you unroll the loop, you're still looking at like minimum of 4 bytes to copy a single word. Anyways, I think that's kind of like the compiler perspective plus some kind of preview of the next slide. So I'll give the next slide to Alex now, I think.
No, I mean, you can explain this slide if you want. I mean, we already touched on a lot of these points.
Yeah, so I mean, copying via loop is expensive, and in terms of bytecode, it's just also not optimal. And I think there's also this like kind of philosophical thing of like, oh, we can do code copy, we can do return data copy, why can't we do memory copy? So you actually have to like kind of maintain 2 different code paths depending on which buffer, the call data buffer, the return data buffer, the code buffer you're copying from, which kind of feels weird because like to simplify the compiler, you actually just use one path and just pick a different instruction. And actually using Mcopy allows us to simplify some code and some optimizations. And then, so like currently the way to do the identity, to do a memory copy is like you use the identity precompile, which is like the precompile at address 4, right? And that's just like a special address that just, it's the identity, it returns the input. And so that's like very commonly used right now to do memory copies, but it kind of has a couple problems. And they all fall under this umbrella of it's like, and I think Alex and Pavel can talk about this a lot more, but they all fall under this umbrella of it's like a precompile, which means that it actually functions as a call. And like, if you look, it's easiest to understand this, I think, by going and looking at like a client implementation like Geth or EVM1 or PyVM or something. And if you like look at how a call is implemented, it's like super complicated. You have to like construct a calling context, you have to allocate memory, you have to like copy these buffers back and forth, you have to copy this memory buffer, the source buffer into the call data buffer for the child call, and then copy it back into the return data buffer and all this stuff. And you have to touch the address. And in fact, I think most clients actually have like a special branch where they look up if some address is in the list of precompiles. So Right. First of all, like having it as a precompile is like super complex. And what happens is that precompiles are considered calls. So like doing governance decisions, like the EIP process or hard forks, they get all kind of lumped together with calls. And so we see here is that like the identity precompile costs 100 gas overhead, which for a memory copying operation doesn't make all that much sense. Like the overhead for doing a return data for any of the other copy ones, return data copy, call data copy, code copy, is an overhead of 3 gas. It's like this massive pricing differential. That can also change if like, and that 100 gas just comes out of the fact that it's like considered a warm contract from the perspective of like, what is that? The EIP-5920, the warm cold addresses. And so it just costs 100 gas to touch the address and then allocate all these extra data structures which you need. And then the other thing is like when you analyze a call, it's not considered pure. Like a call is basically like the most side effectful thing you can do on the EVM. So like if you're like analyzing some EVM code and you see a call, you like consider that like as a very big fence because a call can like kind of do anything. And like, yes, we know it's the precompile, but sorry, it's the identity precompile, which we know doesn't have any side effects. But maybe someday in the future, like calling a precompile contract can have some other side effects. And so if you're trying to like analyze some EVM code, like let's say you want to like fuse 2 writes together or reorder some memory copies, it becomes less easy to reason about if you're using a precompile, which is a call, rather than just the single instruction, which doesn't construct any calling context. It just copies memory. Somewhat long-winded answer from my perspective of why. Alex or Pavel maybe have some stuff to add.
Yeah, I may extend this with some anecdote or maybe just like an opinion piece. Even going back to the origins of like this identity precompile. So I think generally there has been like always a case of debate, what level of complexity of a feature would qualify as an opcode versus a precompile. And even before that, if you look at like early versions of the EVM design, there were no precompiles. All of these high-level features were just part of the instruction set. So something like EC recover, that was an EVM instruction. You know, catch axic.eth was and still is an instruction. SHA-2 was also an instruction. And then, I mean, I wasn't there, but it seems like, you know, there was a decision to move some of these out because they were considered to be too complex to be instructions, and maybe there were some other plans with them. And it feels like the catch-ax instruction, which is kind of like an outlier, it remained an instruction because it was deemed to be really important. And by importance, I mean, even a lot of like the Solidity design is based around the catch-ax instruction. So looking up hash map or like map data structures, it heavily relies on catch-ax. And then I suppose it was realized that memory copying was expensive and identity as a precompile was introduced. And at that point, Solidity only used identity precompile for memory copying. And everything was, you know, kind of all right until the Shanghai attacks. And at that point, all of the call pricing, you know, what Charles explained, how complex calls are, all of the call pricings have been really increased, which basically the identity precompile became useless. It was like extremely expensive. And I don't fully remember when, but shortly after, and shortly maybe in a number of months, Solidity stopped using the identity precompile and relied completely on some internal loops to do copying. And this has been the case since then. And the change, what Charles mentioned in this EIP-5929, the pricing for precompiles have been made cheaper. But even before 2929, there have been, for a couple of years, some discussions of other solutions to reduce the cost of precompiles. In any case, you know, once it was reduced in 2929, Solidity technically could have used identity precompile, and there have been a number of people requesting it to make it like at least decide based on the size of the data structure, because then there's still like a cutoff above or below the memory copying loop is still better, slightly better than calling the identity precompile. But the reason I wanted to say this anecdote is the identity precompile was born out of the same need. It was born to solve this memory copying issue. And it turned out to have solved it in a really bad way, because we got into these precompiles and, price adjustments. And the Mcopy basically tries to rectify this decision and bring the instruction where it seems like it's supposed to be at, because the need is there to be doing copying. And this earlier question I raised, what is like a good level of complexity, what fits as an EVM instruction versus a precompile. And I kind of feel like Mcopy, as Pavel explained, is so simple and relates to already existing semantics in EVM. It kind of really feels like it's an instruction as opposed to be a precompile. The other side of this argument is if you look at the precompiles, the identity precompile is one line. It just returns the input. So it seems to be really not complex enough to be a precompile. Yeah, I'm not sure if you like this anecdote, but this is like maybe a historical overview.
By the way, I think that maybe like you asked, like you were pointing out that like some decision was made early on to make it like a precompiled non-code. And I mean, I wasn't there, but like if I were, I'm just trying to provide some rationale. Like if I were there, or if I were like designing the EVM from scratch or something, there is one technicality about memory copying, which makes it slightly more complicated than the other copy instructions: return data copy, call data copy, code copy. They're not copying from memory, so there's no chance for overlap. So if you do like a call data copy, it's just copying from the call data buffer into a memory buffer, and you're like guaranteed that, like in the client implementation, you're guaranteed these are like totally different buffers. But with memory copy, like there could be some overlap. So when we were doing the spec and kind of actually discussing it, like that came up as like what happens with overlaps. And like after you talk about it or think about it for like a few minutes, like actually most implementations of memory copy will do the right thing, which is that it acts as if you copy the input buffer into a temporary buffer, and then you copy the temporary buffer to the destination buffer, which prevents any like kind of weirdness going on from the overlap. But if you were doing this thing from scratch, you might be like, well, contract calling already does that. It already like copies it to another buffer and then copies it back. So like, let's not introduce an opcode and let's just make this kind of clever precompile, which just returns as input. And this, for the reasons outlined in this slide that Axic and Pavel have been talking about, it makes more sense to have it as an opcode. I think that may have been like a consideration as to why it was originally precompiled. And by the way, at least when I was implementing it, and probably others too, like I wrote a lot of the Geth implementation, and one of the things I did was I did actually verify that the Go runtime, the way that we were copying memory, is actually going to do the copy a linear way instead of creating this temporary buffer. And there's a technique for doing this. Like if you look at the docs for like memmove in C++ or C, it actually just like kind of copies it backwards if like some conditions are met, and that basically acts like it. So there isn't actually a temporary buffer. That makes it kind of work like it is. And in the Go runtime and other language runtimes that I looked at, they do the same thing. There's no temporary buffer. But if there were, then there could be some kind of DOS risk, where you can force somebody to copy a lot more memory than they actually meant to or are paying for with the amount of gas that they're paying.
Well, thank you so much. It was really nice presentation, and I must say that it was easier to see it through the diagram than going through the proposal, especially for high-level understanding. I suppose the presentation may have helped. Thank you for your effort. I see we have a few questions here in the chat. Santosh, if you would like to maybe relay your questions.
I do have a couple of questions here. The first one, which I posted in the chat here, is how does the Mcopy instruction compares in terms of gas cost to other memory copying method like identity, precompile, and unrolled mload or mstore instructions?
Yeah, so pricing is based on words, and an EVM word is 32 bytes. And the price itself is fairly simple. It's just we have a base cost for the instruction, which is 3, and then we charge 3 gas for each of the words copied. And then as Pavel mentioned, if we do expand the memory to like a new area, then you do pay the regular expansion cost as well. In the EIP, we do have an example calculation for copying 256 bytes. And for that size of area, with like an unrolled loop, it would cost roughly at least 96 gas. I'm pretty sure you can save, a few gas here and there, but it would be on the order of like 90, at least like 3 times as much as with the EIP. So with the EIP, it would be around 27. With an unrolled loop would be 96. And in the current case with the identity precompile, it would cost 157 gas. And of course, the bulk of this 157 is 100 for the call cost. So if you would copy larger areas, then the base cost wouldn't increase. So the difference wouldn't be as significant, comparing the precompile versus the instruction. But it is always significantly more expensive to use the precompile. And then we mentioned the EIP-2929 several times, which is the change which made the identity precompile usable again. Before that change, I think we have been in the pricing paradigm maybe for like 4 years before that. So between Shanghai changes and 2929, I think it was like 3-4 years have elapsed. And during that time, this was so expensive that it would have cost like over 700 gas for the same copying. This is just a rough example to give you the pricing. So it's basically like 3x cheaper than mload mstore and like 6x cheaper than the identity precompile, but all of this really depends on your individual use case, what is the size of the area.
Got it. That helps.
I can add one comment to this. So mostly the gas model, gas pricing is most made consistent with some other copying that is happening already in EVM. So we just went with the consistency which kind of makes it simpler, not to kind of overdone it, propose anything new there.
And also, if we can move on to the next question, right? What benefits do static analyzer and optimizer gain from having a dedicated Mcopy instruction in the EVM?
I was wondering if Charles, you want to say a few words, but you already kind of mentioned that during static analysis, any kind of external calls need special consideration. And, but generally external calls, they have to be treated as a black box because they can do anything. And then what more advanced analyzers do, they try to figure out if the particular call case is a call to the identity precompile, and then they can apply the semantics there. And this can work in a number of cases, but if there may be cases where the contract is highly optimized for gas, and maybe in that case, the actual address passed to the call, the address of precompile may not be a constant. It may be duplicated in the stack from like far away. So it may become more challenging to figure out if the particular call is to the identity precompile. And you don't have any of these issues with the instruction because it's just clear what the instruction is. So it definitely is much easier to handle in static analyzers. But I'm pretty sure that there are a number of like highly advanced analyzers who can deal with the current solution. The Mcopy instruction will make it cheaper and easier to analyze contracts utilizing it, of course.
Another thing about analysis is also kind of it's like a defensive consideration, which is like protecting against forward changes in call semantics. So like if calls in the future have some kind of side effects, then you need to be able to model those side effects. And actually right now calls, even a static call already does have a side effect, which is it adds the called contract into like the access list. So, I mean, just continue about access lists, like there's already different transaction types with access lists. If you want to like analyze which contracts does something touch, like Alex was saying, like it starts to get problematic because like the contract address could be added dynamically, or could make, for example, the transaction harder to parallelize if they're all contending on the same address, even if it's the precompile, but like maybe you actually have to run the contract in order to find out that it's the identity precompile, or maybe it's actually not decidable, or it's the identity precompile in some cases. And so, yeah, I think it being a call, like Alex said, it's like a black box, and that makes a lot of things a lot harder. Like, yes, you can have heuristics, but with the EVM being Turing complete, like some things are not decidable, and it just makes analysis more easy to reason about if you have a dedicated for instruction. Like Alex said, you just see the Mcopy and you kind of know what it does.
Sure. Thanks. Yeah.
Ronnie, if you would like to relay your question, please.
I was just asking why they choose 5e instead of 5c or other specific opcode slot.
I think I remember why it's that. I think originally that was different number, but yeah, that's what Charles already sent. At some point, we realized we actually struggling with allocation of opcodes because, well, this kind of natural, maybe as you mentioned, 5c would be like more natural. And that actually causes problems because whenever there's like some additional EIP that maybe does something different, proposes different instructions, it happens also, it selects this natural number that is following existing opcodes. And I think that was case for the transit storage instructions, tstore and tload, or maybe something else. I don't know. I guess that we had a lot of conflicts in these opcodes, which I think it's not like technically very important. But it was actually quite a lot of work to constantly like changing these numbers, because that means you need to go to the implementation. That's probably the easiest part to change it, but you need to kind of correct all the tests you already create for this EIP and so on. And there's like big coordination issue with these. And finally, Dano, who is working on the Bizu client or Besu, just come up with the big table of opcodes, EIPs that are actually considered for inclusion, and we just sorted these by the current proposals, so everyone gets like its number for now, and we don't have to go back to this. And yeah, I would need to open up some implementation, but I think there won't be any gap. I think that's already filled with something else, probably for Cancun, but I might be a bit wrong about if it's actually about the transit storage, but it's like this is the case.
Cool. Maybe if I might go with one last question before we end this call. I would like to understand how this proposal ensures the backward compatibility, right? With the already deployed contracts that might be using Mcopy instructions.
I'm not sure who wants to answer this. So I can say only this, that yeah, it's not like fully backward compatible for the reason that you can kind of, I don't know how to put it, like artificially try to use opcodes that is already unassigned to any instruction, and this unassigned opcode has defined semantic and it just aborts execution at this point, and we are kind of changing the behavior of this opcode number from the day that's activated, right? So that's the breaking point. I'm not sure we dig deeply to find if anything is broken by these, and I don't recall if we did it for previous changes as well. So like for regular contracts, that's rather not an issue. It's kind of, you would need to design it specifically to be broken by this, because we kind of already decided that if you want this specific behavior that you want to abort execution at some point, which kind of every unassigned opcode works for this, but we picked one of these and we decided we'll not ever assign instruction to it. And this is this FE opcode. And the rest is kind of either it's really messy contract, or it's like it's done on purpose just to be broken by these. So I can comment about, maybe Alex and Charles has a bit more experience with these.
I think it's kind of analogous to like push zero. Yeah, I pretty much agree with what Alex just said, which is like we are kind of already reserved. If you want the semantics of like an invalid opcode. So right now, if you use 0x5e, the contract will abort with, exceptionally. And that's right now, like the convention is, if you want to do that, you should use the invalid opcode 0xfe, and kind of no compiler that I know of or handwritten code is really going to be using 0x5c. If you could write a contract which like happens to have 3 or 4 things on the stack, and then its behavior kind of changes after the hard fork. But this applies for all new opcodes.
Maybe here's the time to plug EOF, the EVM object format, which actually solves this problem because you can only deploy contracts with assigned instructions. And so this problem wouldn't actually arise. But as Charles said, this problem has been there since the beginning. And there are certain cases of introducing changes to instructions or new instructions where this has been considered more thoroughly. I think this really mostly applies to removing instructions or changing semantics of them, but it applies to every single case when we introduce new instructions. So there's nothing, I guess, nothing new.
Very well. Thank you so much. I think we can take this opportunity to even invite contract developers to let us know, let your team know about if there is any contract breaking because of, the backward compatibility. If they do not have it and they want to integrate 5656 and it's breaking their contract, they can let the team know more about it. And on EOF, I'm happy to share that we are trying to get Dano on these calls sometimes in October to maybe talk a little bit more about EOF proposals that the team are building on. I know it's time to wrap up. I have a few small questions that I quickly want to take it up with the team. As on the proposal, currently the security consideration is DBA. I was just wondering if there is anything specific under security consideration that implementers should keep it in mind.
I think one thing that should be kept in mind is to make sure that your client is actually doing the overlapping memory in place and not with this temporary buffer, because that is actually a DOS vector.
Great. And about testing, I was wondering if the proposal was included with DevNet 8. I know DevNet 9 is going to be launched next week, and hopefully it will be there because it's going to be a feature complete upgrade. So was it included in DevNet 8? If so, was the performance as expected or anything that may have led a change in the spec of present EIP?
That's a good question. I don't think I have full information about it. The proposal is definitely part of DevNet 8, and I can't tell really how early it was included, but probably one of the earliest DevNets actually, because to my knowledge, that's one of the earliest EIPs that were implemented for curriculum upgrade. So we don't, as the Epsilon team, we don't really actively participate in DevNets because we don't maintain a client to participate in. So what I can't tell how much it was exercised on DevNet, but on our side, we are pretty confident in that testing coverage, because we created I think big suite of test case with all the combinations of different kind of overlapping. And yeah, so from one hand, the instruction is relatively simple, but we still exercise this. But these are let's say static tests in a JSON format you can run your client on. The DevNets, I think, work a bit differently, but there's usually some kind of transaction spam generators that inject a lot of activity to the DevNet. But I can't really confirm if the Mcopy instruction was exercised by these and what's the stick.
I would consider here no news is good news. If no client team has tried to reach out to the authors, perhaps it is working as expected, if included. Otherwise, we'll get to know more next week when we have DevNet 9 live. All right, it's time to wrap up. Do you guys have any message for smart contract developers or users in general?
Yeah, I think that there's maybe one message from the Epsilon team, and yeah, maybe Charles can also speak regarding Vyper. But yeah, I think in Epsilon we would be happy to hear any feedback on any other missing feature, or if you're not happy with on the EVM. As Pavel mentioned in the beginning, we do review external proposals, and we also have a number of proposals ourselves. So if you have any questions regarding EOF or EVM Max or any related proposals, or if there's anything else you would like to propose, feel free to reach out to us, and we may be able to help you with some feedback on the proposal.
From Vyper side, I think I'm personally pretty happy about the CIP, and I'm excited for it to go in, and it's going to bring some performance improvements that maybe you won't think about every day, but will be passed on smart contract developers and users in terms of bytecode size and improved gas usage. So yeah, I'm excited for Cancun. I'm excited for people to start using it. And yeah, I'm really happy with how this EIP turned out.
Awesome. Pavel, Alex, Charles, we thank you for joining us on PEEPanEIP and talking about execution layer proposal 5656. We look forward to follow DevNet 9 and public testnet to see EIP-5656 deployed on the mainnet with Dencun upgrade. On this note, thanks to all our YouTube viewers for watching and podcast subscriber for listening this Dencun special episode on ETHCAT Herders channel. Should you have any question on this or any other topic, let us know at ETHCAT Herders Discord. Check out the description for more info. We'll be back with another interesting talk. Until next time, keep watching, keep listening, and keep sharing your love with Ethereum Cat Herders. Cheers.